Okay, so my name is Brady Rogers. Uh, this project was done by me and Dalton over Atomic Mass. So let's get started. As you can see, we got some relevant formulas for atomic mass. Here's just the standard atomic mass on, you know, how you find the mass of an atom. You're going to use Avogadro's number, which is right here. Um, Average masses indicated in the periodic table are then calculated using isotopic abundances. This is basically saying every atom is gonna have a different, or every element, every atom, not element, every atom is gonna have a different mass because it's gonna have a different type of isotopic abundancy. This is going to be used as a technique to measure mass to charge ratio of an ion. Moving on. Um, Here's just a little cleanup slide. Mass is the basic physical property of a matter. The mass of an atom or a molecule is referred to as an atomic mass. Atomic mass is going to be seen right here under, this is going to be an element, lithium to be precise, but this is going to be the mass right here. The average or the atomic mass is used to find the average mass of elements and molecules to solve stoichiometry problems. Key points indicates the weight of an atom or molecule, used to find the number of neutrons. Stoichiometry calculations connects the atomic structure to a chemical reaction. With that being said, the atomic mass itself is going to be able to, you can use that to find a lot of more things as the atomic mass or the not atomic mass can be used for your calculations on finding different types of you know relatability to that atomic mass itself. Okay, moving on. Relevant fields, pharmaceutical development. Atomic mass plays a crucial role in the development of new drugs. Molecular formulas are important to having the right number of atoms in each pill we take. Atomic mass is used in this process. Whether it's prescriptions, it's going to have different types of, elements in there. All these elements are going to be calculated to have a correct amount of whatever it is for the user. And this is all by just, the AMU of it. Scientists use atomic mass to design new properties for a product or changing current properties slightly to fix the customer's needs. Slight change in the mass of an atom can completely change the final product. That being said, each atomic mass it's precise. With that being said, the calculation needs to be precise. And if it's not precise, you can mess up the whole thing and make something that it's not even valuable for a customer need. It's going to be completely something different. Nuclear engineer. This is just one of many things nuclear scientists use daily. Fusion of an atom needs to be precise, and these scientists use atomic mass carefully to fuse atoms. Fusing atoms, is crucial for scientists, just because the simple reason of whenever you combine atoms, you create a new substance. With these new substances comes new products. So everything needs to be interconjoined correctly and precise. Quantum computing, a variation in isotopic mass can affect the vibrational and electronic properties of a qubit material, which in turn can affect the coherence time. Understanding and migrating these effects requires precise knowledge of the atomic massage of isotopes involved. With that being said, it's just this slide alone, you can kind of see how tedious and crucial it is to know the atomic mass itself, because everything's going to fall under, that's kind of the foundation of creating a new substance. And without the atomic mass, can't really do it. It's important to understand that atomic mass is going to be really significant in finding, you know, in finding new things or creating something. So, moving on. Relevant scientist. I'm not going to try and even pronounce that first one. But that one, he was famous. It was a famous chemist in the 1800s that used hydrogen atom with the atomic weight of 2 to be the standard mass to calculate every other atom from. So just from, that one hydrogen atom, he was able to find a lot more to atom discovery. Then we got Mr. Dmitri, a Siberian chemist who discovered a periodic classification of the elements. The atomic weight of the atom made for more stability and understanding the atom. The properties of the atoms were similar. Atomic mass were placed together, later creating the periodic table in the 1871. He left gaps in the table as for unknown elements at the time would find their place. So just kind of like the dude before this, he was able to find just, one little subtle thing with one of them and was able to calculate, more. So pretty cool. And then Mr. John Dalton from England. Dalton created today's modern atomic theory with having a love for weather and discovered that Earth's atmosphere was 80% hydrogen and only 20% oxygen, which is absurd to me considering you need oxygen to live. Apparently you need hydrogen more than oxygen, I guess. But yeah, there's pretty cool scientists that were able to find out a lot from just a little by, the atomic mass. Moving on. Motivation for experiment with atomic mass. The primary motivation for Dalton's original experience was to move chemistry from qualitative guesswork to quantitative science. Before the atomic mass unit, chemists knew that substances changed during reaction, but they did not know specific amounts were needed. The motivation was not to find the true weight of an atom, but to find the ratio of weights so chemistry could become a predictable mathematical discipline. That being said, science is based on facts. Science is also based on numbers. Atomic mass is a number. So with just a number of an atom or an element, you're able to find a lot. Moving on. Why atomic mass matters. Atomic mass plays a massive role in turning chemistry into precise and measurable science. It also allows people to compare elements, chemical formulas, and understanding basic substance structure / motives without atomic mass. Predicting reactions and working with compounds would be much less. So, it's kind of self-explanatory. Without atomic mass, there's a lot of gaps that can be occurring with calculations. So it's important to understand that atomic mass is not just a mass; it's a foundation. Moving on. Challenges. Calculating atomic mass is not always simple because most elements exist as a mix of isotopes. Each isotope has a different mass, and their natural abundance must be taken into account. This makes the process more detailed and can lead to small errors if not calculated carefully. These variation of isotopes make an atomic mass more complex than initially it appears. As a result, scientists must rely on precise measurements and calculations to ensure accuracy. So that being said, elements are always going to have a different set of isotopes, which is going to affect a lot of things. So it's important to take in everything. Yeah. Moving on. Atomic mass. How is it determined? Scientists first identify all the isotopes of an element. They then measure the mass of the isotope. Sorry. They can measure the mass of each isotope to determine the abundant each one is in nature. Using this information, they can calculate a weighted average that represents the element as a whole. It's kind of same thing as I was saying before. It's pretty tedious, but it's reasonable. So atomic mass related to isotopes. There's there's always going to be more in one and less in one. So it's important to understand that isotopes play a big role in calculating the atomic mass. So for carbon 12, atomic mass is based on carbon 12 standard, which serves as a reference point. One atomic mass is defined as 1/12 the mass of carbon 12 atom. This isotope was chosen because it is stable and provides a consistent way to measure and compare all elements. So it's kind of just, a reference to, whether you're trying to find something extremely difficult. It's always good to go back to carbon 12. It's going to be it's going to keep the calculations grounded, as you can see. Benefits of understanding. This is kind of like a little example. An element has an average atomic mass of 35.5. If one isotope of a mass is 35 AMU and another has a mass of 37 AMU, why is the average atomic mass not a whole number? This is going to be relevant because the atomic mass unit isn't tied to how atomic mass is calculated using isotopes. It is also tied back to the concept that atomic mass is the average value rather than a single whole number. So even though they may be whole numbers in the question above, the answer is going to be completely different by a long shot. It's going to be something wicked. Lots of decimal places. So also, while mass number, protons plus neutron, is always a whole number for a single atom, atomic mass is an average, which is why you see decimals on the periodic table. The average value within the atomic mass is necessary because it's the building blocks for chemistry, medicine, and even geology. In industries like pharmaceuticals, knowing the exact weighted average ensures that medication is created with perfect ratio of ingredients in every time. While isotopes act as a hidden code in nature, scientists use the carbon dating to figure out how old an object is, which is probably the most interesting thing that I think comes from this. I think it's I know it's not the most beneficial, but I think it's just really cool to see that you can tell how old an object is just by the isotopes in it, and then the being able to relate that back to the carbon dating. So yeah, I think that's, I mean, atomic mass is cool and all, or whatever, but carbon dating is pretty legit. So for the summary, atomic mass is decided by taking an average of all naturally occurring isotopes of an element. As said before, each isotope has a different structure, meaning different number of neutrons, which changes its overall mass. What's intriguing is how atomic mass is not a whole number because of isotopes. It is important to understand how slight differences in atomic structures can affect overall mass and behaviors of elements. The carbon atom is the base for the AMU. 1/12 of a carbon is the generic weight used to measure any atom today. That was discovered in 1803. Which is hard to believe since something of that size can be even considered. In summary, atomic mass explains the total mass of an atom based on protons, neutrons, and also considering isotopes through a weighted average. This concept is important in understanding chemical reactions, calculations, parentheses within the parentheses, stoichiometry. Sorry. And how matter behaves in both science and real world events. And if you want to, look through our references on where we got everything, here's the page. I appreciate your time for watching this video, but I gotta go, man.